Okay, so we're going to look at Cramer's rule. And Cramer's rule, again, is another way to solve a system of equations. We found using Gauss elimination or row operations was one way to solve a system of equations, but it became very tedious. And if you look at it from a historical point of view, that when we look at this method, it's better. It came after, and it becomes more efficient than row operations. And it's based on determinants. Well, we know that for a matrix to have a determinant, you have to have a square matrix. And so the system I'm trying to solve, which is on page 24 in your workbook, if you wanted to follow along, or if you want to do the problem on page 24, that's fine as well. It's number one. But the system is a three-variable system, three equations, and here's the augmented matrix. And since we need a square matrix, we're going to go ahead and just erase the solution column for now and find the determinant of this 3 by 3 matrix. And if you're really good at finding determinants, then you should do this on your own, not necessarily watch me and just make sure we get to the same value. So I will find my 3 by 3 determinant. Just erase this, there we go. So, I will do the math, and you can follow along or do it yourself. So I have 4 plus 1 plus -9 minus -6 plus 3 plus 2. So that's 5 minus 9 is -4. And then this is minus a -1, so I get -3. So I get the determinant of this matrix that represents the coefficients is -3. Okay, that's going to be extremely important for our final answer using Cramer's rule. So I'm going to keep track of the determinant is equal to -3. Now, what we want to do is find 3 more determinants. And we basically are going to take the solution column and go back into our coefficient column, which is this. I'm sorry, coefficient matrix. And we are going to take turns replacing this column into this column, find its determinant, and then replace this into this column, find its determinant, and then take this and place it in this column, take this and place it in that column, and find its determinant. So let's find the x one first. So we erase the x values, and we replace it with the 6, -5, 14. Okay, this we're going to call the determinant with respect to x, because we've replaced the x column. And it's a 3 by 3 matrix, so we will go ahead and find the determinant. And again, if you're really good at finding 3 by 3 determinants, as you should be, then do this on your own. Don't follow me, and see if you come up with the same solution. So let's see, here we go. Again, I won't talk, so you can watch, or do it on your own and check. Okay, so I got -3 as the determinant. I got -3 as the determinant with respect to x. So I'm going to keep track of it by maybe putting a subscript of d sub x equals -3. Okay, excellent. Now, let's do the same process, but this time, when we take our coefficient matrix, we are going to replace the y column. And we will replace the y column with 6, -5, 14, because that was the solution column that now we're going to solve for the determinant with respect to y. So again, you find your 3 by 3 determinant, and I will do that. And you know, if you are good at finding determinants, and you should challenge yourself to be good at finding determinants. You do the calculation, I'll do the calculation, and we'll see if we come up with the same answers. Okay, so I got -9. Negative 26 minus a negative 17 should give you -9. So we're going to keep track. D sub y, the determinant with respect to y, is equal to -9. Okay, last time. Okay, so we will replace the z column with the solution column. So I have to put back my y column, 1, -2, 3, and my z column used to be that in the coefficient matrix. I'm going to replace that with 6, -5, and 14. And again, one more time, let's find this 3x3 matrix, the determinant of this 3x3 matrix, and see what we get. You do the work, I'll do the work, and we'll see if we get the exact same answers. So I got 6. I got the determinant with respect to z is equal to 6. Now, this is what Cramer's rule says. Cramer's rule says if you have found the determinant and then you subsequently find the determinant with respect to x, y, and z, in other words, you have replaced each of the columns separately with the solution column and solved them, then your x solution and your y solution and your z solution are obtained by taking the ratio. So the ratio of dx to d, in other words, -3 to -3, which was 1. So it means x would be 1. For y, it would be dy compared to d. So -9 compared to -3, or 3. And then for dz compared to d. So 6 over -3, which is -2. So our ordered triple is 1, 3, and -2. Okay? And you should always check your work to see, maybe I'll pick this last solution. 1 plus 9 is 10, minus a -4 is 14. And you could check the solution and the solution, it would also work. Now, because this solution is based on determinants, and because this solution is dividing by the original determinant of the coefficient matrix, it must be clear that you cannot have a 0 in this denominator. If this determinant of the coefficient matrix is 0, then you cannot use Cramer's rule. And oftentimes that comes up as a question on the assessments. I may give you a matrix and you need to realize or calculate that, oh, wait a minute, this matrice's determinant is 0, and therefore I cannot use Cramer's rule. Okay, so definitely anticipate that on the assessment. It's something to look at, and be careful of that Cramer's rule only works for determinants that are non-zero, and obviously to have even a determinant, you have to make sure that you have the same number of equations as you do variables. They must be square, in other words. Okay, so there is another example on your homework to practice. It's number 2 on page 25. Solve that by Cramer's rule. And again, take a look at the process, and hopefully that, that would make sense to you.